In this video, we will dive into the concepts of Apex unit tests. Whenever we want to move an application to production instance which includes Apex components like classes and triggers, it's a mandatory requirement from Salesforce that these components should have at least 75% of the code coverage. Now, what is the code coverage? Before we talk about code coverage, let's talk about test classes and test methods. Test classes are special classes in Salesforce in which we can write methods which will call the methods of the non-test or functional classes that are part of an application's functionality. These methods in a test class are called test methods. Test methods are meant to be executed to test as many lines of code from the classes or triggers as possible to make sure that the code in these Apex components is executable without producing any exceptions. After we execute a test method, Salesforce returns to us a percentage value which represents how many lines of code of an Apex component was executed by that test method against the total number of lines of that Apex component. This percentage value is the code coverage. If the code coverage is more than or equals to 75%, Salesforce will allow us to move an application to production. Otherwise, it will not be allowed. Note that the process of moving an application from one Salesforce instance to another instance is called deployment. We should not use the Apex unit tests only to achieve the code coverage requirement for production deployment, but should also use it for quality assurance, regression testing, and documentation. Quality assurance. Apex unit tests help maintain the quality of our code by catching bugs early in the development process. This means fewer issues in production and smoother experience for users. Regression testing. Whenever we make changes or add new features, unit tests ensure that the existing functionalities aren't broken. They act as a safety net, allowing us to confidently enhance our application. Documentation. Unit tests also serve as documentation for our code. They provide examples of how our Apex methods are supposed to work, making it easier for other developers to understand and maintain our code. Now, let's get into the practical side of things. Writing Apex unit tests involves a few key steps. Number 1. Set up test data. We will need to create test data that our test methods will use. This is done using the test setup methods. Number 2. Call our Apex methods. Next, we will call our Apex methods that we want to test, which will use the test data that we created. This simulates the actual use of our code. Number 3. Assert the results. Finally, we will use assertions to check whether the results of our methods match the expected outcomes. This is done using the system.assertEquals method in Apex. Let's look at a simple example. Suppose that we have an Apex method which will update an account record's name with the value that we provide. This method accepts two parameters, ACC ID, which is nothing but the account record ID, and then the name, which is the name that we want to change the account name to. First, we will create a test class for the class unit test demo. We will name this test class unit test demo test. After the class is created, we will add the annotation @istest to mark this class as a test class. Inside this class, we will create a test method with the keyword test method. Note that a test method should be static, should return void, and cannot accept any parameter. Also, neither the test class nor the test method needs any access modifier or access specifier like public, private, or protected, since these methods get called by the system itself. Additionally, we will create a test setup method with the similar syntax of a test method that should be annotated with @test setup. Salesforce's unit testing framework calls this method every time any test method of this class gets executed. Note that a test class can have multiple test methods. And if there are multiple test methods, before executing each test method, Salesforce will execute this test setup method. In this test setup method, we will create and insert an account record with the name My Salesforce Adventure. In the test method, we will query the account record that we created. Note that the test method do not have access to the instance data unless we explicitly specify using the @istest notation extension see all data is equal to true. The reason that by default test methods do not have access to the instance data is because these test methods might get deployed to different instances like sandboxes and production, and those instances may not have the correct data that these test methods may need to perform the necessary business operation and validation of the functionalities. Also, it is advisable to create and use our own data that is specific to the use cases that we want to test in the corresponding test methods. Once we query the test account, we will use its ID and pass a new name to the Apex class method myApexAdventure. Now, we will run this method by clicking on the Run Test button. The test execution results can be monitored in the Tests tab. We can check the code coverage by opening the Apex class and clicking on this drop down in the top left corner. Since the code coverage is 100%, we can see that all the executable lines of code are blue. Blue means that the lines were executed successfully. If it was red, we can consider that those lines were not executed. We are done with the code coverage part. But what about the actual validation of the functionalities to make sure that it is working as expected? This is how we can do it. We need to go to the test method, and after we execute the Apex method, we need to query that account from the database again, and using the system.assertEquals method, we should validate that myApexAdventure is the name of that account that was modified by the method that we called. Here, the system.assertEquals method compares the two parameters that we pass to it and throws an exception if the values do not match. If the values do match, it does not throw any exception. Since this method gets executed successfully here, we can conclude that the Apex method that we are trying to test works as expected. Before we wrap up, here are a few best practices to keep in mind when writing Apex unit tests. Use test data factories. To avoid duplicating the code and pre-populating all the fields based on the different validations, use test data factories to create test data records. Isolate tests. We should ensure that our test methods test and validate a single piece of functionality, and the other test methods in the class are not dependent on the data or the outcome of the first test method's execution. Test single and bulk records. We need to make sure that our code works for both the single and multiple records to ensure that it handles large data sets correctly. Handle all scenarios. We should cover all the possible scenarios, including positive, negative, and edge cases. The more scenarios we cover, the better our application becomes over the period of time. If you like this video, please do like and share. If you want to receive more of such informative content, please hit the subscribe button. If you want us to make content related to any Salesforce or Salesforce related topic, please do let us know through comments.